Hi guys, today I came up with another machine learning algorithm, which is a decision tree. So decision tree is the machine learning algorithm which is used for classification and also regression. So this algorithm falls under the category of supervised machine learning. I have already explained what is the meaning of supervised in my previous videos. So supervised means what is to be predicted is already there in the training data set. So one of the benefit of decision tree is it is used for both the purposes, means classification and regression. So that is why even it is referred with the short names CART, which stands for classification and regression. So when you say tree, means set of nodes can be there. So decision tree is a flowchart like structure in which internal node represents a test on the attribute. So you can graphically represent a tree as, so this is a node and we call this as a root node, and this root node might be having children's, right? You can have children's. Okay, so this is a root node or parent node, and this one is internal, so this is called as internal node. And this one, this one, this one, and this one, so these are no leaf node or terminal nodes. So a test on the internal node is performed, then you'll be getting an output. For example, if you write some condition, so if it is true, if the value of that is true, if the condition result is true, then you choose this path, else you choose another path, right? And so as I mentioned, these are known as terminal nodes, means the last node, leaf nodes, and these are these two are the internal node, and this is the root node. So here you need to understand the terminology of decision tree. And a branch represents the outcome of the test, and leaf node represents the class label. So when you traverse from root to the leaf node, you can get some outcome. So that is possible by traversing to the branch. The path from root to the leaf node gives the classification rule. So rule can also be expressed in the form of if-then rules. So remember, there are two types of decision tree. One is classification tree and another other one is a regression tree. So if your target variable is categorical, then you build a tree, and that is called as classification tree. If your target variable is continuous type, then you build a tree, and that is called as regression tree. So decision tree is one of the simplest machine learning algorithm which is used for classification and regression. Let's say you have a problem to predict whether the bike is good or not. So how can you decide? So this is from the data set itself. So you can build a model, and that model will make the prediction whether the bike is good or bad. So you can also consider mileage as an important factor. So as mileage is continuous, you can also apply decision tree regressor if your objective is to find out the mileage. So these are the few terms you should be knowing. Root node, which represents the entire population. Okay, it is entire population. So root node is split into multiple sub nodes. And the splitting is a process of dividing a node into two or more sub nodes. Decision node means the node which is splitted into multiple parts. Okay, decision node means when a sub node splits into further sub node, then that is called as a decision node. And leaf or terminal node means which cannot be splitted further, so that is leaf or terminal node. And pruning is a process where you remove some set of subnodes. When you have many branches of the tree, then you can remove some set of nodes. That is called as pruning. For example, let's say if there is some tree in front of our house and the tree has grown bigger, then what do? We cut the branches so that the tree looks pretty well. So like this here also same. So if the tree has many branches, so decision cannot be made easily. So that is why we have to cut some branches. And branch or subtree means subset of the tree is called as a subtree. Parent and child node, so root node is parent node, and if it has a child, then that is called a child node. So these are the few terms, so you should be knowing about the decision tree. Now the question is how the decision tree is built. What is the algorithm for that? So these are the three steps involved. So first you have to place the best attribute of your data set at the root of the node, and then that is splitted. That is splitted into multiple subnodes or subsets. So based on some criteria. So I'll be telling you what is that criteria. So a node is split into multiple subnodes, and step 1 and step 2 are repeated until you find a leaf node in all the branches of the tree. So these are the three steps involved. So when building a decision tree classifier, you can improve the accuracy by tuning the parameters. So I'll be talking about that. And a tree may be also be overfitted, means sometimes the data is overfitted to the algorithm. In that case it may not give you the correct results. So by applying pruning or some other parameter tuning, you can make the model to perform well. Now the question is, what are the attribute selection measures, means splitting criteria. Importantly, there are two. The first one is classification error rate, means it's a fraction of observations, training observations in a region that do not belong to the most common classes. I'll tell you, I'll take an example for this. And Gini index, so it's a measure of variance across the different classes. And information gain and entropy, information gain depends on entropy, and once you calculate the entropy, from that you'll get the information gain. So let's get into detail. So what do you mean by classification error rate? So for example, you have a data set and where you want to predict whether the someone buys an iPhone or Android. So it's a binary classification problem. Let us assume that there are 25 observations, means 25 rows, nothing but 25 phone buyers data is there. So out of 25 observations, 10 bought iPhones and 15 bought Android. So what is the majority here? The majority is 15, means 10 people have made wrong decision. So we can calculate the classification error rate as the failure, that is 10 divided by total. Total is 25, which is equals to, so 40% error rate here. So the goal is to reduce the classification error rate. For example, let's consider one more attribute, that is gender. It is having two values, male and female. Let us say 2 males bought iPhones and 12 bought Android. So the majority is Android here. So in case of male, the classification error is 2. And in case of females, so 8 bought iPhones and 3 bought Android. So here also the majority is 8 iPhones. So the error is 3. So totally for the gender attribute, 2 plus 3, which is equals to 5, divided by total 25. So the error is, classification error is 20%. Now similarly, if you consider one more attribute, that is age, and it has two unique values, 30 or younger, 31 or older. So in the first value, in the first category, 4 iPhones, 8 Androids. So majority is 8 Androids. So the error value is 4 here. In case of 31 or older, 6 iPhones, 7 Androids. So majority is 7 Androids. So error is 6 here. So totally, in case of gender attribute, 4 plus 6, 10 divided by total 25, which is equals to 40%. Now how the decision tree is constructed based on this attribute, classification error rate. So the algorithm will try every possible split across all the features, and it will choose the split which reduces the error rate. That means if you traverse from root to the leaf node, the classification error rate decreases. So that is the point to be noted. Then another metric is Gini impurity. So this is another interesting evaluation metric where it try to find the impurity. So Gini impurity is to describe how homogeneous, means how pure a node is. So you can say a node is pure, and we denote that by G is equals to 0 if all the samples belongs to the same class. Understand, if all the observations or samples from the data set, if they belongs to the same class, then we say the impurity is pure. Okay, otherwise not pure. So while a node has many, that means many samples belongs to different classes, then we can say a Gini closer to 1 means impurity is there. So here is a purity and here is a impurity. So you can calculate Gini impurity by using this equation. G is equals to 1 minus the summation of k equals to 1 to n pk square. So what is this p of k? Pk is a fraction of sample belonging to the class k. So that gives the Gini value. So let's apply this same on the data set. So here we have two types of phone buyers, iPhone buyers and Android buyers. So we can calculate as 1. So 1 means 100%. Out of 100%, how many iPhone buyers and how many Android buyers? So if you calculate like this, this is one class, this is another class. So iPhone by total whole square minus Android by total whole square, which is equals to, so we have 10 iPhone buyers and 15 Android. So divided by total 25. So the resultant value over here is 0.48. And here, this is the point to be noted. The maximum value of the Gini index is 0.5. So when the classes are perfectly balanced, right? If the classes are balanced, so we'll be having the maximum value for Gini index is 0.5, and the minimum value is 0. So when there is only one class represented in the node, and a node with the lower Gini index is said to be pure. It means that G value, Gini index value should be 0. Otherwise, greater than 0 indicates impurity. Now let us apply the same Gini index on the gender attribute. So in case of male, so 1 minus 2 by total males are 14 square minus this one is Android 12 by 14 whole square. So we got 0.24. In case of females, we are getting 0.40. So we'll calculate the weighted average, which is equals to males 0.24 multiplied by total males, 14 divided by total observation. Total observation is, we have 25, right? 25 plus, in case of female, 0.40 multiplied by total females, or 11 divided by total observations 25, which is equals to 0.35. 0.31. Similarly, if we calculate the same on age attribute, then in the case of first category, you are getting the value as 0.44. In case of the second unique value, 30 or older, you are getting 0.50. So here you'll be calculating the weighted average, that is 0.47. You are calculating the weighted average as 0.47. So a decision tree is constructed with the value reduced from root to the leaf node. If you traverse from root to the leaf node, the Gini value should be decreased. So this is the difference between the classification error rate and Gini index. So when you compare these two, so Gini index is preferred because it will make splits which increase node impurity, whereas in case of this Gini index, node purity is important because we are more interested in the class proportions in each region, means in each class. So the default metric is the Gini index. So there is also one more common rating criteria available, that is crash entropy. So it's numerical, similar to the Gini index, but the computation is slower. When you apply crash entropy, the computation, means model building, is slower. So that's why Gini index is preferred, and it is the default attribute. in scikit-learn. So information gain is also another splitting criteria or attribute selection measure. So to calculate information gain, you need to calculate entropy. So then what is entropy? Entropy measures the impurity. Okay, entropy measures the impurity. Basically, this term also comes from the other fields like in physics and mathematics. Entropy is referred to as the randomness or uncertainty of a random variable x. Even in information theory, so impurity refers to the mm, it refers to the impurity in group of examples. Means if there are set of very no different categories, so it specifies how the samples are drawn and how the samples varies from other classes. So this is an equation. E is equals to minus this sigma of I equals to summation ranging from 1 to C and pi multiplied by log base 2 pi. So pi means is the probability of randomly picking an element of a particular class. So information gain decreases the entropy. So information gain computes the difference between the entropy before splitting. This is a point to be noted. Entropy before splitting the data points and the average entropy after the data set is splitted. So the difference between these two, that gives the information. So the attribute with the highest information gain is chosen when you are applying the splitting. Now let us see how to build a model, how to build a decision tree model. And here we are taking a data set which is iris data set. It is one of the very fundamental data set, and every machine learning engineer should be having an experience on iris data set. So basically this is a flower data, and initially this data set is introduced by the person Ronald Fisher in his paper 1936. The paper title is this: the use of multiple measurements in taxonomic problems as an example of linear discriminant analysis. So this is a very famous data set and also fundamental data set. So as per this data set, so there are three types of flowers. The first one is setosa, versicolor, and then vozinica. So based on the attributes like sepal length, sepal width, petal width, so you can classify the flower into three classes: setosa, versicolor, and vozinica. So we are taking the same data set, and this data set can also be available in different open repositories. So in my case, I'm using the dataset available from UCI. So UCI is the online repository, and this repository is developed by University of Irvine. So there are many different kinds of data sets available for different purposes. So once you guys you can just search out in Google UCI machine learning repository, then it will give you the website. Then just browse that. You can find various kinds of data sets. So this is my data set. So as usual, first we import the libraries, right? So here I'm importing pandas to create a data frame, and this is an algorithm decision tree classifier. As I mentioned before, it can also be used for regression. So if your target variable is continuous type, then you have to import the algorithm, that is decision tree regressor, imported from the module scikit-learn.tree. And these are the model evaluation metrics, classification report and accuracy score, which are imported from scikit-learn.metrics. And we would like to split the data into training and testing. For that we are importing train test split. So once these are imported, so I'm just getting the data from the URL. So this is a user defined variable URL, and I'm specifying the path. And this data set is not having the column names, so I'm creating a Python list here, call names, which is equals to sepal length, sepal width, petal width, and spaces. And then iris is equals to pd dot read csv, and data is read from URL, and it is not having the header. Header means column, so that's why we are writing header equals to none. Then how to apply the column names? So names is equals to call names, so these names are applied, and then data frame is created, and we are displaying the header part of the data. So these are the first 5 arrays. So this data set is equally distributed, and we have 150 observations, means 150 rows, and totally there are 5 columns. If you check the shape of this, so 150 rows and 5 columns, and our target variable is this spaces, means flower type. There are 3 unique values for this: iris setosa, iris versicolor, and iris virginica. So based on sepal length, sepal width, petal length, petal width, you are classifying the figure as setosa, versicolor, or virginica. Now iris.info. Info means it gives the information about the columns. So 5 columns are there, 0 to 4, and our target variable is spaces, which is object type, and the remaining 4 features are float 64-bit type. So this is a clean data. We don't need to do any cleaning or pre-processing methods. So feature columns equals to so this is Python list. I'm creating a list here with the column name sepal length, sepal width, petal length, petal width. Then x is equals to iris of features. So always we have to separate our data into x and y. Understand? So always we need to separate our data into x and y. So this part from here to here, so this is your x, and this is your target variable. So we split this data into 4 parts. Okay, we split this data into 4 parts. This is x train, this is y train, this is x test, this is y test. So 4 parts the data is split into. Next so y spaces, target variable is assigned to y, and then we are splitting the data. So train test split applied on x and y. Test size is 0.2, means 20% testing data, remaining 80% is used for training, and we are specifying random state to 5 here. And we have already imported an algorithm, so I'm creating an object to the class CLF, which stands here classifier, which is equals to uh, decision tree classifier. If your problem is regressor, you can import decision tree regressor and then build a model. So my problem is classification. Why? Because my target variable is object type. Then fitting the data to the model. So model has learnt. And for more information, you can also take and help decision tree classifier, and you can also check out what are the different parameters, like criteria by default is Gini. So you can see criteria means the function measures the quality of the split, and the possible values are Gini and entropy. Like that you can take a help of this. And if I give some sample values, so 5.3 means sepal length, 3.6 is sepal width, 1.4 is petal length, and 1.1 is petal width, then what the model will make the prediction. So model has predicted it as it is a setosa type. My model has predicted the sample as setosa. Now we have 20% testing data. Then make the prediction for that by using our model, and the results are stored into the y predict, then displaying the values of this. So these are the prediction for 20% of test data. You can see there are some samples which are classified into versicolor, setosa, virginica, right? So these are the prediction, and we can calculate this, we can get the accuracy. Okay, you can get the accuracies. So accuracy is one of the metric to evaluate your model, and this is the formatting. So 0.02f means 2 decimal digits, and we can, this is the function accuracy score between y test. What is y test? Means actual value. And what is y predict? This one, what the model has predicted. So if there is a difference between these two, we say error, otherwise no error. So the accuracy over here is 93%. My accuracy is 93%. And so one of the problem with decision tree is overfitting. Okay, overfitting means data is not fitted properly to the model. Model has misunderstood the data. So we can check the overfitting by getting the score. So there is a predefined method classifier dot score of fitting xtrain dot values and ytrain dot values. So this will give us the training score, and I want to get the test score as well. That is xtest dot value and ytest dot value. Now let us see the score values. So in case of training, the model has very good performance. 1.0 means 100%. When it comes to test, it is 93%. So almost 7% difference is there. So there is no difference. So if there is a difference between training score and test score, then we can determine that there is overfitting. Otherwise, no overfitting. So here 0.7% is there, so not that much big, not that much difference. So which means we can say no overfitting. This is one of the interview questions. So what is the difference between a score and accuracy score? So accuracy is the normal metric. So the difference between score and accuracy score is the use case. So score is a generic method which is implemented by all the classifiers, and this will evaluate the performance of a model on a given data set. So the score returns the value which is between 0 to 1, and score means it gives the mean accuracy of the model on tested data set, whereas the accuracy gives the accuracy on the complete data set. So it is used to calculate the accuracy of a classification model. It takes the true label, true value, and what the model has predicted. So that is what we did here. The difference between this is true, this is what the model has predicted. So it gives the, based on the correctness, it will give us the accuracy. Okay, so this value can be in the range of 0 to 1, representing the accuracy of the model on the testing data. Then what is score? So now the question is actually when to use score and when to use the accuracy score. So accuracy score is a normal method, so which can be applied on all kind of data. Even score can also be applied on all kind of data. So we can use score when you want to evaluate the performance of a model on a given data set. Means it is useful when you do the comparative analysis on some data set. So here the point to be noted is score method returns the mean accuracy across all the classes, and this might not be suitable for imbalanced data sets or when you have a multi-class problem. Score is not useful. So in that case, consider accuracy score. So use the accuracy score when you want to calculate the accuracy on the complete data set. Okay, it is used to know how well your model is performing on each data set So it is useful in case of also imbalanced data set, and also when your problem is multi-class. In that case you can use accuracy score. So then this is one of the evaluation metric, confusion matrix. Confusion matrix also gives us the performance of your model. It summarizes how the classification is done, how many samples are correctly classified, how many samples are incorrectly classified. So this is the matrix actually. TP means true positive, FP means false positive, false negative, true negative. So TP means true positive, means it's simply an outcome where the model correctly predicts the positive class. Let's say your model has, this is 0 class. Okay, 0 class, this is 1 class. You got some number. Okay, you got some number, for example, out of 100. So out of 100 you got here, so 90 classified into 0 class and 10 classified into 1 class. And there can be also sometimes some values here, over here and here. So this part refers to misclassification into zero class, and this value refers to misclassification into one class. So this is how the samples are correctly classified into zero class. This one, how the samples are correctly classified into one class. This one and this, so incorrectly classified. In other terms, you can say true positive means the positive class occurs when the model predict an observations which belongs to a certain class, and the observation actually belongs to the that class only. So means correct. True, that is true positive. This one is true, then model has predicted no, so that is true negative. False positive means it's an outcome where the model incorrectly predicted the positive class. Okay, incorrectly predicted the positive class, that is false positive. False negative means here the outcome where the model incorrectly predicts the negative class. Okay, incorrectly predicts the negative class. And this false positive also known as type 1 error, and false negative also known as type 2 error. So by getting the confusion matrix, you can also evaluate your model. So you can import it confusion matrix from scikit-learn.metrics, and having a matrix between y test actual, y predict means what the model has predicted, then you'll be knowing the matrix. You can see 8 samples correctly classified into 0 class means setosa. This is 1 classification into class 1 means versicolor. This is classification into class the last one, that is virginica. So misclassifications, this one. Even you can evaluate your model by using a classification report. So classification report completely gives the details how the classification has been done with the measures like precision, recall, F1 score and support. Then you might have a question, what are these attributes? So precision means it's an ability of a classifier not to label an instance as positive which is negative. So in other terms we can say simply positive prediction rate. Recall means ability of a classifier not ability of a classifier to find all the positive instances, we say sensitivity. And F1 score is the mean of harmonic mean of precision and recall, and we expect the value for F1 score as 1.0. Best score value is 1.0. Less than that, if it is closer to 0.0, that is the worst F1 score. So you can get the classification report between the y test and y predict, and you can see the last attribute support means how many samples classified into setosa, 8 samples. How many samples classified into versicolor, 11 here. And how many samples classified into virginica, 11. And out of that, as you have seen the confusion matrix here, there are 2 misclassifications. So that is why F1 score has been decreased in case of versicolor. In case of versicolor, and also here uh, there are less small, there is a 92% support, 92% F1 score for virginica. So there could also be a smaller small set of misclassification into the class virginica. So the overall accuracy that we got is 93%. Even you can compare what is the actual and what is the predicted. So the accuracy is 93%, means 7% it can make mistakes. So we are creating a data frame here between the what is the actual value and what the model has predicted. So now 7%. So the test size is 30 to 30, means out of that you can see here actual versicolor. So both are same, means actually versicolor even model has predicted versicolor. No error, no error, no error. Here also no error, no error. Here there is error. You see the actual is versicolor, but the model has predicted virginica, so there is one error, one error. Here also one more error, right? Two, same, right? And here Same, no error, no error, no error, no error. Here also no error, no error. I think no errors more. So 2. So 2 by 30, which is going to be point 7, almost closer. If you round it up, going to 0.7. So it mapped the accuracy. So 93.0.93 plus 0.07. So that is going to be 100%. So we have cross-checked the performance of your model. So decision tree means it gives the output in the form of graph. So for that we can use matplotlib, importing matplotlib.pyplot as plt, and we are creating a list of the features. So fn means feature name, sepal length, sepal width, petal length, petal width, and class names are setosa, versicolor, virginica, and having a subplot here, number of rows 1, number of columns 1, and the figure size is 12 by 2, dpi means dots per inches, and you're having a tree. Okay, plot tree, plotting the classifier, feature names, class names are applied, filled true means the data is filled, and you're also saving the figure. So when you run this cell, you can see the output. So this is a decision tree. So first, if the petal length is less than or equals to 0.2 sorry, less than or equals to 2.45, if it is true, you come here, else you go here. So this is terminal variable, terminal. This is no leaf node, setosa. So here virginica, versicolor. So if you traverse the path, this one here is virginica, like this. You know, if you traverse the path from root to the leaf node, you are getting the class outcome, either setosa, versicolor, or virginica. And you can see the Gini value. So 0.66 here. When you move to down, it is decreased, right? Gini value is decreased, means impurity is decreased. So as you can see, there are many branches. So for this, you can apply, you can do pruning. Pruning means you can cut some branches. So in order to cut some branches, I am applying one of the measure here. That is one of the condition, that is a minimum impurity decrease, setting the threshold value to 0.1. Means a node is splitted. Okay, a node will split if the impurity is above the threshold value. If more than 0.1, then that is splitted, otherwise not splitted. So I'm building the model again. So classifier 1 equals to decision tree, random state 5, minimum impurity decree value. So again building the model. The process is same here. Now plotting the model again. So now the number of branches are reduced. So if you traverse this path, outcome is setosa. If you traverse this versicolor. If you put this, then virginica. So this is a simple model, right? So like this, you can improve the performance of your model. That means if there is some overfitting, then try to cut some branches by applying some measures. Then the tree size is reduced. The number of branches are reduced. So like this you can build a model. Now let's talk about the plus and minuses. What are the advantages and disadvantages? So as I mentioned, decision tree is one of the simplest algorithm which is used for both classification and regression. And this is the only one algorithm for which you can display the outcome by using graph. And interpretation is very good. So you can have classification rule, and if you simply use those classification rule, you can make a decision on your test data. So in terms of interpretation, decision tree is only one of the very best algorithm. And prediction is somewhat, because you are when you select this, for example, if your condition is this, then no, you are not considering this part. So that's why prediction is somewhat fast. Features don't require scaling, and model learn automatically, and it tend to ignore the irrelevant features. So that is the these are the advantages. And then disadvantages are the performance is not that much competitive when you compare with other algorithms. So it is one of the simplest algorithms, and there can be possibility of overfitting, and small variations in the data set can also result a different tree. For example, here we just change or we just applied single condition here, minimum impurity decrease, then totally the tree has been changed, structure has been changed. So this is a simple tree, but whereas here you have many branches and nodes. So that is the point to be noted. And it doesn't tend to work with very small data set. And even if your data set is unbalanced, imbalanced, in that case decision tree algorithm will not give you the better results. So this is about decision tree. I hope the things are clear and you have understood better. Even if you have any queries, you can also reach out to us. Do subscribe to our channels to get more updates on machine learning training.